In this lesson, I will continue talking about isolating footing. I will take now real example, I will take example, and then I will solve this example, this footing in SAFE. I have a building, or it's a villa actually, this one. Let's open the villa. I will take one column from this villa, one column, I will take the reaction. I will put this reaction in SAFE, in some isolating footing. I will put footing, I will see the result, how much the size I want, how much the thickness, what the reinforcement I should choose. But I will take the reaction manually. I will not export this now. Next lessons I will export this. But now I will take, for example, this column. I have this, as we think, take 3D. This is villa, like a villa. I will take go plans. I will take one column, this column. Let's see, all floor, go up, or whole story. Now I choose one column, show selected object only. Then don't care about this because this is in ETABS. I will take this to SAFE. I will take the reaction here. Anyway, I have big course in ETABS in Udemy. You can check that course and enroll it if you want. This column, let's take the size. Let's open Excel to register this number. The column size because I need this. The column size is 40 by 60 from ETABS. Is 40 by 60. What I have else, what I need now the reaction here. I will ask, go to plan, it's more easy, go to basement, this is the point. I don't make run, I will make analyze first, because if I need reaction I should make analyze. Now it's finished. Let's take from here reaction. We have self weight, finishing, partition, life load. Let's take life load first. I will take all this. As we seen, it's give me, you should table, you should here. He said Fx 1 kN, forget, don't care. Fy 3, it's very small number. Fz, this is vertical, 372. Let's write here 372 life load. V, vertical. Also M is very small, I will take the M from the other. I want self weight, finishing, partition together. I have a combination, it's all dead or life, all. Then apply. Then let's see here. The total vertical, it's 3130. 3130. This is total. 3130. This is total vertical. For that, dead load vertical, it's equal this minus this. This is dead load, this is life load now, this is total. Then go back. I have moment, forget, this is Fy, it's 28. I will take Fy, it's 28 kilonewton, and I have, this is moment 3, it's very small. Let's take this. Mx is 35. Mx is 30. Mx is 35 kilonewton meter. Now I have, this is, I don't need it, forget, because I take it only to calculate the dead load. I have now life load, I have total dead load, I have Fy, I have Mx. This is the size also. Let's now from serial report, as we seen in previous lesson, here we have how much. If we have, I will consider my foundation in minus 1.5. That means this is our bearing pressure. It's 250 kilonewton, it's square meter. Let's back here. Before I go to SAFE, CSI SAFE, I will know how much I should expect the foundation. I expect there's manual way to calculate in fast. Be careful, this is not ultimate load, this is service load, and that's what I want. In foundation, we take service load, then we calculate the bearing capacity, the soil pressure. We don't take ultimate, we don't take factor load. We take service load, only load, without safety of factor. Because why? In soil there's safety factor, it's 3. They consider our safety factor in the soil report. For that, we don't take the maximum load, we don't take ultimate load, we take only service load. This is very, very important comment. Please be careful. Equal this plus this, dead and live, all together. Divided, how much soil bearing capacity? It's 250. This is kilonewton and this is all kilonewton meter. This is the area what I want. It's a 12.5 meter. I want 12.5 meter for this foundation. You got what I did? I divide the area of foundation. Let me match property. The area of foundation equal the load divided on the bearing capacity. The area equal load, this is load total, or this is total, divided in bearing capacity. How much bearing capacity here? It's 250 from soil report. From here it's 250. I need 12.5. Let's take this is the area. How much the dimension? If I consider it's square, that means equal SQRT for this number, for this number only. Enter. I need 3.5 by 3.5, but I should go more because I don't be at the limit exactly. I will consider 3 point because I have also moment, I have some horizontal load. I will consider 3.7 by 3.7. Why I did this? I can do this in SAFE. I can try. I make 2 by 2, then bigger, then bigger, then bigger, up to get the exactly number. But here I will take this number, then I will go to SAFE. Maybe I need to modify sometime. Maybe sometime it will be ready. Don't have to modify anything. Let's now go to SAFE. I have this CSI SAFE. I will make a new model. This is new model. The code ACI. The unit important. metric unit I use. Then I will single footing. There is here some ready one, but okay, don't care about it. Then we will finish. The load I will consider 0 now. Then thickness I will consider 600. It's okay. This is 2 meter from each side. I will change everything now. Okay, I have this is example he make, but I will modify this example to be as my example. I will delete this. Now I don't have any. I will put draw point in the center. Then I will put the load in this point. Assign load data, point load. First I have live load. How much? The dimension of column he asked me. It's 60 by 40. That means it's 400 millimeter, 600 millimeter. How much the load now? He asked me gravity. This is the live load. Be careful. Live load it's 372 kilonewton. Be careful about unit. 372 kilonewton. He asked me add or replace. Add. Moment I will consider here everything 0. Then okay. Then select this point again. Then assign load data, point load. It's same size. He leave it. How much the dead load total? 2758. How much mx? I think there's mx 35. For more save I will consider my said 35. He asks you about if there's horizontal load, it's X. What we have, if Y is 28, I will consider here 28. Sorry, 28. Add or replace, it's okay because there's no dead load. Another add, okay. Now if you want to be sure, don't click right in the point, go to load, you seen dead load, this is live load, this is, then cancel or okay. Now the foundation, how much the foundation here? I think he bought 4x4. You seen, this is 4x4. I will delete. There's too many ways to fix, but I will delete. Then here, then I will delete this 4 point. Now I have this our point, it's there's load here, this is important. I will here choose this one, you see. He asked me about property, I will choose footing, I will check after that. Then trim in the slab edge, no. Then one click here, he draw the foundation. What this point? It's nothing, I will delete. It's not deleted anyway. This is for I think maybe for the grid. Anyway, now I will select this footing. I will go to define before soil subgrade property. I'll modify this. It is 250. This is just a name. But here, how much? This is important, as I said before. How much it's 30,000 kilonewton meter. Be careful, kilonewton meter. 30,000. Then okay. Then okay. Right click in this. Then here for the slab soil property. Not this. This. It's 250. Then okay. Then okay. You see some grid point here. This is soil. Now let's define material. I have this concrete. My concrete, it's C40. That means here it's 40 multiply 0.8. This is FC dash, not FCU. This FCU. Then here it's 25. How much E? E is as usual. It's I have 32 SQRT square root. Then multiply 4,700. It's 26. This number. Copy. Then Control V. No need for this. All no need. Delete. It's enough. Then okay. Then okay. I have rebar. I should change also. R460. That's what I will use. This 460. All other it's okay. Then okay. Then okay. Then define. Let's change the slab thickness or footing. This is what I want. Footing. I will consider the thickness is, let's start from 50. 500 millimeter. It's C40 footing. It's thick plate. Yes. Then okay. Then okay. Here right click. It's F50 now. Let's make design strip. How much it's have as a slab. Go to slab to understand what that means. That means this strip going half meter right, half meter left. This first strip, this is A. I will make B starting from here to here. Then I will choose this one. Then I will make replicate. Replicate. How many I need? For example, 10. It's okay if it's more. The increment in X and Y. This is in Y. This one going in Y up 1 meter. Then okay, as we see, I can delete this. I don't need it. Then this point delete. I will select this one. Then go replicate. Same, but here I need 1, 2, 3, 4, 5. 5 enough. The increment in the X, not in Y. Here is 0. Then okay, I have this. This also I don't need it. Delete. Even you leave it, it's okay. Now I have this footing. I bought the load. I choose the thickness. I choose the material. I bought the soil. I add the strip for the design. Then save. Here save foundation. Let's make as ulating booting. Then example 1, then save. Let's see the result. Make run. You have run analyze or run analyze and design. Let's start run analyze before, it's more faster. We don't add load combination for your information, we forget that. Anyway, from define you can add it after the combination. Add default design combo, strength and service, and strength and service only, normal and ultimate. Then okay, let's check. This is service, 1 dead load. This is service also. This is ultimate 1.4. This is ultimate 1.2, 1.6. This is American code. This okay. This to U ultimate. This service. Then okay. Then again, let's make analyze and design again. We will check two things in the first. We will check the soil reaction from here in service load, not ultimate, not this service. This again from here, show reaction factory, as we've seen, share reaction force reaction. I will choose soil pressure, I will choose two combination, I will choose this and this. I will check both. Let's check first one this, then apply. How much maximum allowable? 200, 250. How much here we get? 247, 48. It's okay. You seen why? Because I calculated manual here. Then I will check second one. Maybe it's okay, maybe no. 278, it's more. You see, it's more. We have problem in the dimension. We should add more dimension, or if we add more thickness, maybe it will solve. Why? Because here is more, but here, if you check here, it's 216 only, because he not consider this foundation is very stiff, because the thickness is small. 50 centimeter is not big thickness. We can add more thickness, we can add more size, whatever you want. Then cancel, then close. We have some problem in the reaction, soil reaction. Let's check the bunch. That means I will check if the column will bunch this foundation or no. Let's check the bunch. The bunch coming in the automatically in the ultimate, it's 1.4. It's too much. You shouldn't go more than 0.95, less than 1. For that, I should add more thickness. Let's start with the solution. Okay, from define, slab property, F30, F50, I will make it F70, 700. Then okay. Then okay, I will not add any size now. I will add only the thickness. I will see then reaction. Maybe the distribution of the load will be better because the foundation is more thicker. Let's choose reaction from here. 2, this is most critical. Soil pressure, apply. How much? It's 261. Just I need, you see it's going lower, but it's still not okay. This I have still problem. Let's check the bunch. It's 0.85. It's okay. Now you can maybe go to 750 or 650. Leave it as it is. It's okay. Don't go to add the limit exactly. Maybe if there's any modification after that, you should edit this, or if there's some limit, it's okay for you. It's better. Let's add more area. How will add more area? From here I will select one area. There's one way, it's very good. Edit area, expand. You see, expand or shrink, but I will expand. How much I will expand from each side? I want to add 5 centimeter or 5 centimeter from each side. From here 5, from here 5, 5, 5. If I add 5, that means in each direction I have 10 centimeter. That means 50 millimeter each side. Then okay, as we've seen, it's going bigger now. Let's make analyze and design. It's very fast because it's very small. Let's from here, soil pressure, then apply. You can go here. It's 250, 250. It's exactly in the limit, 250 point. I prefer to add more 5. Don't be at the limit. Don't be at the limit. Select, go, edit area, expand 50 millimeter. That means I add now 100 millimeter, 10 centimeter from each side. Run, analyze and design. Then from here, reaction, same, apply. Let's see, 240, it's okay now. Let's check the bunch again. It will not affect, same 0.84, it's okay. Let's choose the reinforcement from slab design. This one, I will go to strip A and B together. I will take B for the bottom reinforcement. The major reinforcement is the bottom. As we said here, if we see, this is the bottom, this is the reaction of soil, here the tension, here the compression. No need for top, only need for bottom. From here we can choose value. You should here, let's put uniform reinforcement. I will expect 16 H15 H150 millimeter in two way. I assume I have 16 H15. Then I will ask SAFE, I need more or it's just enough? I need bottom, impose minimum. If there is minimum reinforcement, I will, if I need less than minimum, choose minimum. That's what this means. Best strip. Then I ask him, if there is more reinforcement, give me as a bar 16 or give me as 20, for example 20. Then it's okay, no need for this. Show reinforcement extent, apply. You see, it's, if you remove this, see what will happen. This what you want. If you put this what you want after you put the basic mesh. For that I need more. You see, I have some issue. For that I will choose 20. You know, this road is very big. It's if you back here, you see it's 3000 kilonewton. It's around 300 ton. For example, it's, I choose T20. It's okay. Now I need only here 2 bar more. You can ignore 2 bar more. Let's see if I need top reinforcement. He asked me for some top. Why? See, he asked me for some top. Why? Because the compression in the concrete is more than allowable. You should add more thickness or you should add some top reinforcement. I prefer to add some thickness of concrete better. Or if you want, sometime you can choose very small mesh of, let's see, 12 H 150. You see, it's okay. It's enough, just enough. You can small mesh. Yani, now for our foundation, I will choose 12 H 150 top mesh. Bottom, this is from SAFE. It's 20 T20 H150 bottom. Thickness T equal is 70 centimeter. Dimension equal, we assume 3.7, but it's now 10 centimeter from its side. For that it's 3.9 multiply 3.9. We see, this is our result. You can draw this in AutoCAD. I will give you some example in drawing after that in AutoCAD. Now we finish isolating footing. That we solve all issue. We design. We have load X or Y, vertical moment. We can do whatever you want here. Thank you.